This is EUREKA Online, where you have the opportunity to learn at ease some of your subject courses like mathematics, physics, chemistry, biology, statistics, and computer science, and other courses or subjects that you are doing. Okay, so like I started earlier, we have been dealing with kind of function where we discussed about even function, odd function, and neither. Okay, so we will continue from there. We're going to solve some examples on even function, odd function, neither function, and also show you some graphs that relates to each of those functions. Okay, so let's assume we have a y equals to, or let's just say f of x. F of x equals to minus, okay, equals to, let's say, x squared minus 4x. 4 raised to 6. Okay, we can be asked to show which function does it belong to, either even function, either odd function, or neither. So let us see. By the time we finish the testing, we can now know which function this question or this equation belongs. Okay. So and what we're going to do is just picking minus x to substitute for x in the equation. We pick minus x to substitute for x in the equation. And we know I've given you the condition for even function. For an even function, f of x minus f of x must be equal to f of x. So you can see that this is f of x. So we'll substitute x minus f of the function. We should be able to give us the original question. Okay? So now, also, that is condition 1. Condition 2, we can have an odd function. Odd function is if we are able to substitute minus s for x, we should be able to give us, minus into f of x. Okay? So that means we are going to use minus to multiply the original question. So if we give out the original, we use minus to multiply to get factorize out minus, and we're able to use minus to open the bracket, give us the original question. You can easily say that it's odd function. Okay, for neither means that it does not belong to any of this equation. That means any of these conditions. That means f of minus s is not equal to f of s. Substitute. Also, condition for the okay, let me just say even function. This one is odd function. And this one is neither odd nor even. We also have this condition f of minus s is not equal to minus f of x. It's not equal to minus f of x. So this is also neither. It's also neither. Okay. So we can easily solve this above question, and whatever we get, we will make our conclusion. Whatever we get, we use it to make our conclusion. Okay. So we can substitute now. So solution f of minus x equals to minus s all squared. Okay, so we have used the minus s to replace the s. So we are not replacing the power, but replacing the x. Then minus 4 into minus x is 6. Nothing will happen to this constant. It's only the variable that are going to replace. Okay, so that means we can finish our question by saying we are having, okay, we'll kick out minus 1. Just kick out minus 1, and each of them will carry their power, then the remaining s will also carry its power. So we have a minus 4, we also have minus 1, kick out minus 1, raised by 6, and then we have an x raised by 6. Okay, so that means we are going to have this implies that we are going to have a minus 1 all squared. Minus 1 all squared. If the power is even, then the negative sign disappears to become plus. So we are going to have plus 1 there. Plus 1 times s squared, we have s squared. Then we have a minus 4. So this also is, the power is even, we should change it to be plus. Okay, it will affect this. So plus 1 times s raised by 6 equals s raised by 6. So we notice that when we substitute minus s, it gave us the result, gave us the original question. We say this is even function. Even function. It implies even function. Okay, let's take other question. Let's take other question to see what we can get. So that is an even function. That is an even function. Let's say this. We have x raised by 3 minus x raised by 5. X raised by 3 minus x raised by 5. Okay? So if you have something like this, we can easily say solution. Solution. We want to check which function, which kind of function it is. So we are going to go by substituting minus s for x. So that which gives us minus s raised by 3 minus s raised by 5. So I said we're going to kick out minus 1. What we kick it out, we have a s minus s equals to, we have a minus 1 raised by 3 into s cubed. Okay, minus the minus s, sorry, minus 1 raised by 5 into x raised by 5. So this gives us, we have when we have a minus negative sign and raised to odd, that means we are going to have minus 1. So minus 1 times s cubed, we have a minus s cubed. This one also is raised to power of odd, then it becomes minus 1. So minus 1 times this, we have a minus s raised by 5. So this minus s raised by 5 times this minus become plus s raised by 5. Become plus s raised by 5. Okay. So let's see. So f of minus s equals to minus into s cubed. By the time we factorize out minus out, we notice that this now is now the original question. We say this is odd function. So this is odd function. Let us take other example. Let's take other example. You can see odd function. You can see by the time we factorize out a negative sign, we can see. So by the time we open the bracket again, we get back this. So like we are not trying to open it to get back. We are trying to see if we can get back the original question. Alright. So let us check another question. Let's check another question whereby we can see that let's say f of s equals to minus x raised to power x raised to power 7 minus x raised to power 2 minus 8. Okay, let's see if we can be able to handle this. Let's see. Solution. We have an f of minus s equals to, substitute minus s for s and let it raise 7. We have a minus into minus s raised to power 7 minus the minus s raised to power 2, okay, and minus 8. So 8 is a constant, we can't replace it, but we can only replace the variables, which is alphabet. Okay, so that means we have f into minus s equals to, let's kick out minus 1 from here. Don't forget there's 1 minus here already. So we have a minus into minus 1 raised to power 7 into s raised to power 7 minus into minus 1 all square s all square minus 8. Okay? So that means we are going to have f into minus s equals to, so this negative sign become, because it's raised to power odd, then change to see maintain the negative. Where it's even, it will have a plus, like it will be minus. So minus times minus become plus. The plus 1 times s equals 7 become s equals 7. So this also we maintain plus. So you see how minus. So that minus s squared minus 8 minus s squared minus 8. So we notice that it did not go back to the original question. And if we factorize that minus 1, we can't give us the original question. So because of that, we say this is neither even nor odd function. Okay, so let us give you some exercises. Let's give you some exercises. Okay, before that, alright, let me give you some exercises. So, just submit it, and 1. Show that the function below represents any of even, odd, or neither function. Show that the function below, the equation below, show that the equation below represents any of even function, odd function, or neither, or okay, so let's see. That's the number 1. Roman figure 1. We are going to have f of s equals to s squared plus 6s cubed minus 8s minus 1 2 f of s equals to s cubed over 3 minus 6s squared over 3. F of s equals to s cubed minus s raised to power 6 over s. Okay, so we can also have 4 f of s equals to s raised to power 6 minus 7s squared plus 6s raised to power 8. And then we have the fifth one, f of s equals to raised to power 8 plus 6s raised to power 9 plus 10s raised to power 10s. Yes, let's do that. So just make sure play with this. So comment, put it on the comment section and let us hear you. Let us see how you are able to do that. Okay. So we progress on the same even, odd, and even, odd. We progress on the same even, odd, and neither. Even, odd, and neither function can also be represented by using a graph. We can be represented by using graph. Okay? So for even function, there's going to be a symmetrical bisection, or it's usually symmetric at the y-axis. Even function is usually symmetric at the y-axis. So when you plot your graph and get something of this nature, you see we are having even function graph. Even function graph. So where we have a y here, we have an x minus x minus 1. So you can see that it's symmetric. It's symmetric. So you see, yeah, you see. Also, graph of odd function. Graph of odd function will be symmetric at the origin. We cut the graph and make it symmetric at the origin. So when we have this, so we have this, we have this, y minus y, s minus s. So this is origin. So this is origin. So you can see it. You can see it. So you can see that this is odd function graph. So cut it at the origin. So we can have the odd neither function graph. For neither function graph, it will not be that of even, it will not be that of even or that of odd. So we can have it in this form. Sorry. Have it in this form. So have So having that form. Can have in different form. But it will not just be even or odd. So we can have a y, x, minus s, minus 1. Neither odd. So we can have a different form. Can have it like this. Neither. Alright. So we can also discuss what we call composite function. Composite function. Composite function involves a way of substituting one equation for the variable in another equation. Sometimes you can see FOP you can see FOK, you can see KOF, you can see KOFOB. Okay, we can have it that way. We can also have it in this form. F, PS, something like this. You can have it like this. You can also have F, PS, something like this. So that what we make is just carry this equation of P, substitute it into substitute it for the variable of F. For example, after substituting, you have to simplify. Them. For example, if we have f of s equals to 6s squared plus 7, okay, and we have k of s equals to 7s cubed minus 1. We can also have p of s equals to s squared. Okay, so we can be asked to find one fs into ks, 2 f into ps. So just substitute them into it. You can also have FOBOK. That is it. So let us solve them. So the first question is fs ks. So carry this ks, substitute it for fs. And we're going to have a solution. F of s equals to 6s squared plus 7. So substituting this ks into it, that means we're going to have f of s ks is equals to 6 into 7s squared minus 1 all squared plus 7. So 6 into, you can see we have moved this and substitute it for 7s cubed. 7s cubed. Okay, we have picked this k and substitute for s here. So when it's coming, it means that x is squared. So we have and there is 6 outside. So 6 into 7s cubed minus 1 all squared plus. For this f of s, we have 7. So let us simplify it. F of s, k of s, which is equals to. So let's open this bracket. 6 into 7s cubed minus 1, 7s cubed minus 1, so we have 7. So let's open the bracket, open this bracket before you use 6. Don't use 6 first. So that will give us 6 into 7 times 7, that's 14. S cubed times s cubed. It's going to give us 6. Because when you are multiplying, you add the power. That is 9. Okay? According to law of indices, you have to add it. So that means you have s raised by 6. So 7s cubed times minus 1, we have minus 7s cubed. So minus 1 times 7s cubed, we have minus 7s cubed. Minus 1 times minus 1, we have plus 1. So plus 7. So that means that we have 6 into, so we are having minus 7s cubed minus 7s cubed, give us minus 14. Oh, sorry, this one is 49. Sorry, 49. So we have a 49 49 s raised by 6, s raised by 6, then minus 14 s plus 1, so we have plus 7. So we can easily say that we have a 6 times 49. 6 times 49, 6 times 9, we have a 63, isn't it? Okay, 6 times 5, 6 times 1, 6 times 4, we have a 64, we have 64, yes. Okay, 6 times 5, 30, 6 times 4, we have a 64, 6 times 6, we have 24. Okay, we have a 64, we have a 4, we have a 24, we have a 304. Okay, isn't it? Yeah, 304. So 304, 304. Okay, s raised by 6 minus, we have a 24 here too. 24. 6 times 6, we have a 6. So we have a 4. So we have a 4, 24. We have a 2, that is 84. 84 SK. So 6 times 1, we have a 6. Now 7. The bracket will be totally removed. So that means finally, f of s, k of s is equals to 304 s raised by 6 minus 84 s cubed plus 13. Plus 13. Okay, so that is how to handle that. So the second question. The second question. Let us substitute P of s for f. Then we are going to have P of s for f. We have the f of f into P of s, which is equals to 6 into s squared all squared plus 7. So f P of s equals to 6s raised by 4 plus 7. So that is answer to that. Then the last of them all, which is this is number 2. Number 3, we have f o p o k. So we pick this, substitute for p. The answer we'll get, substitute it for f. Substitute for f. So I'm going to wrap this up. That will be easy to solve. So I can have space. So then this will give us, so f o p o k will give us, pick the k and substitute for p of s. So when we do that, the answer we got is substitute for f. So firstly, we're going to do p ok, which is equals to 7s cubed minus 1 all squared. So we have a POK. Don't forget that K in P first, which equals to 7s cubed minus 1 into 7s cubed minus 1. So we have a POK is equals to 49s raised by 6 minus 14s raised by 3 plus 1. So I've done all the protocols. So we'll pick this and substitute it for f of s. that means we're going to be having FOPOK will now be equals to 6 into 49 s raised to 6 minus 14 s cubed plus 1. Okay, all square. Don't forget that the s is having square. That's it plus 7. Okay, so let us quickly finish this. Let's quickly finish this and see. So which give us 6 times 49, we have a 304 the other time. Okay, before then, let's open the bracket. FOKOP, sorry, POK, which will give us 49 s raised to 6 minus 14 s cubed plus 1. Open another bracket. 49 s raised to 6 minus 14 s cubed plus 1. So that will be brackets and plus 7. Okay. So let us say we notice that 49 and 49 and 49 give us 2